Okay, we move on to calculation of consolidation settlement under a foundation. So in the previous chapter, we calculated the increase in the vertical stress in soil caused by a load applied over a limited area decrease with depth Z measured from the ground surface downward. So basically, that was on uh, module 5, wherein we tried to solve for the vertical increase. That was basically stress distribution. We tried to compute for the vertical stress on a certain area, on a certain point due to a particular load being applied or within the area. So, however, the increase in the effective stress should be the average increase in the pressure below the center of the foundation. So the values can be determined by using the procedure described in our previous discussion. So if we try to assume that the pressure increase varies parabolically, we try to use the Simpson rule. So we try to estimate the value of the increase in the vertical stress. We have here delta sigmas of prime average is equal to sigmas change delta sigmas of T prime plus force, delta sigmas of M prime plus delta sigmas of B prime all over 6. So you have to take note that this one represents the effective stress pressure on the top, on the middle, and on the bottom of the layer. So respectively. So we have here a sample problem. You're going to calculate the settlement of the 3-meter thick clay layer that will result from the load carried by a 1.5 meter square footing. So the clay is normally consolidated. So we're given with this footing 1.5 meter by 1.5 meter size. It has a depth of embedment of 1.5 meters. We have a load being applied which has 890 kilonewton. So we're going the clay is normally consolidated, so we make use of this equation to compute for the settlement for normally consolidated clay. So we have to compute for compression index, which is 0.27, our H, which is 3 meters, convert that to 1 to mm, so that is 10,000. Our S of O is 1. So therefore, our sigmas of O prime, that would be equivalent to 3 times 15.72 plus 3 times, this is saturated, 18 minus 87 minus 9.81, then half of this, so that would be 3 all over 2 times 17.3 minus 9.81, since this is also saturated, so we get a value of 85.58 kilonewton per meter. Okay, we make use of this equation to compute for the average increase in the vertical stress. We have to take note, we have to get the value of the average stress increase on the top, on the middle, and on the bottom respectively. Then divide that throughout by 6. So for this one, we can prepare a table. So we have to identify our M1, our Z, our B, our N1, Q, I, and the delta sigmas of prime. So L over B, which is 1.5 over 1.5 equal to 1. So basically M1 here would be, all throughout will be 1. So Z, that is the distance, that is the depthness. So let's start with 4.5, 6 meters, and 7.5. We're only up to 7.5. So that would be 4.5 up to this. Then afterwards, we're going to have 6, and the last one will be 7.5. So afterwards, we have to identify our small letter b, which is width all over 2, and n1, which is z all over b. And we have to identify our q. Our q is which is 890 all over 1.5 by 1.5, which means that we're going to have here 890 divided this by 1.5 by 1.5. So the result is equivalent to 395.6. So all throughout our Q is 395.6. So basically, we can identify our I, wherein our I here is, we need a value for N1 and M sub 1. So basically, the result here would be, from our previous discussion, we can identify our I, and we got here our result for our I. Once we have the value now for our I, we can identify our increase on the vertical stress, which is equal to Q times I sub 4. This I sub 4, so you simply have to multiply this one times this, so it gives us this specific value. And once you have this value, you can now get our the average increase in the vertical stress. You simply have to substitute. This is on top, this is on the middle, this is at the bottom. So divide by 6, that gives us 12.26 kilonewton per meter squared. So basically, we can have our we can have the value now for our settlement using our equation. For normally consolidated, simply have to substitute the given parameters. It gives us 23.6 millimeters. So that ends our discussion for compressibility of soil. So basically, when we talk about compressibility of soil or soil compressibility, we're talking about the decrease in volume of the soil, due to the application of mechanical loading. So if you're going to compress saturated soil, that is now termed as consolidation. So basically, we have identified the different consolidation settlement. We're talking about elastic or immediate. We have the primary and the secondary consolidation settlement. So thank you.